All right, now I want you to think about something real quick, and this is going to hurt your head. Natural selection and evolution are theories, they're not laws. These are not things that are proven to always be true no matter what, right? So, this is a very important thing to understand. It also doesn't mean what you might think as a theory, which is just something that you've pulled out of your keister. This is not what theories are. Theories are things that match multiple forms of evidence over many, many experiments that seem to all explain one generalized idea. Not, oh, look what I thought today, so that's a theory. That's a very different experience. And we're going to go through some of these pieces of evidence, and this is by no way, shape, or form the complete, nor is it the depth that you would need to really come to a final conclusion. It's just to give you an idea of what it is they're talking about. So fossils. Fossils are imprints or the actual body of once living organisms. These are things that are no longer here, or they might still be here, but in a different form or whatever. But they're organisms that died some time ago, and it can show you how these organisms have changed. Uh, and looking at fossils and seeing how they change will give you some idea of how they changed, in particular, to over time. Geography, biogeography in particular. You look at, for example, a bird in this island and a bird in this island. You're like, why is the birds on this island? These two are related. They're very, very related. These birds somehow flew here, maybe, or flew here. Somehow they get their butts over here, and now they live here. So then the question is, well, all right, why is it that this bird's black and this bird's white and brown? Right? You're like, oh, I don't know. It's obviously that the coloring of this bird is less of an advantage on this island than this coloring. This coloring works better. Maybe this island had a volcano, and after a volcano, the ground is black, like ashy, and that makes this bird easier to hide with a black background and make it harder for who knows, right? But showing the variation from one organism to another on one area to another shows how they've adapted to that new area. And that's a piece of evidence for evolution. Looking at the embryo, how an organism goes from fertilization to born to adulthood makes a big difference. Okay, it tells you like how related they are. For example, these two organisms both have a larval states that are similar, and it gives you an idea that they have some kind of relationship, some kind of common ancestor to them. So, identical larvae have different adult body forms. Similar embryos have diverse organisms. It's this idea that looking at these organisms from when they began will give you an idea of what they look like now. You'll also run into some stuff by looking at anatomy. For example, something called homologous structure. Homo means same, log is writing. So same writing structures, right? And if you look at the human hand, it's got metacarpals and carpals and phalanges. Okay, so you have the red bones, the green bones, the yellow bones through here. A mole, a bat, also has similar bone structure. So do whales. So do dolphin. The bones are a little different in shape, but the pattern of bones is the same. And this is a good sign that these organisms had a common ancestor not too long ago. Now, I'm not saying that we are the same as a mole and a bat. I'm saying that there's enough similarity to suggest a common ancestor to us. That we moles and bats, if you go Doctor Strange and you turn back the time all the way back to when those three organisms didn't exist, there was only the common ancestor. We were all that. You also get analogous structures, structures that are not shaped the same but have the same function, like an insect wing and a bat wing are not in any way, shape, or form the same structure, but they have a similar function, which is kind of neat. And this is evidence of a non common ancestor. There's also vestigial structures that, to me, always are a interesting topic. So, for example, ostriches can't fly, okay, but yet they still have wings. I don't know if you know this. Snakes have a hip bone, and I'll just show you quickly. They actually have a bone that used to be a hip. Uh, this is close to it, and the bone kind of floats. Here it is. See it there? That's where legs used to attach. And as weird as that sounds, whales have a hip bone. Now, don't get me wrong, you can't put the hip bone on a whale and connect legs to it and stuff. It has been reduced as an adaptation over many, many, many generations, but it's still there. So these are vestigial structures. We have an appendix. It's a piece of our intestine that used to handle vegetable, like when we used to eat grass and stuff back in the day. And we don't do that anymore. So that's an example of vestigial structures. These are all pieces of evidence of evolution. Now, you might think, well, that's not very good evidence. And that's fine. You can think that. There's plenty of people who do think that. But that's not the same as to say that there's evidence of anything else, right? Everything else is just guessing. But the only evidence that exists so far is this. And that's it for section 4 of chapter 10.